Hello, everybody. Welcome back to video 14 in this series. I'm actually just preparing some lectures here, and I decided to record it and evaluate and adjust my notes for the lectures coming up. And instead of deleting the videos afterwards, I thought I'd go ahead and put them on YouTube because other people might be interested in the stuff here. So far this is video 14. We've been doing quite a bit in this series. Made a landscape and added our character to it, created our character. But we haven't got any light in the scene yet. We're almost ready to start moving our character, but there's no light, so we can't see anything. So um, we need to add that. And I also thought that there's a lot of stuff we want our character to do. So jumping into the character script is going to be a lot. So I thought adding with the light, there's probably an easier introduction to scripting that we can do there. Uh, so I'm going to move this character over here by these trees. I noticed some trees not too far off here. Oh, undo that. Let me look from the top and move this character over close to these trees here. That way there's something to see. Yeah, that'll probably work. Maybe up a little. I think he's above the ground there. Well, I'll have him stand on the ground or slightly above it. That'll work. So when we run the game, we're looking at these trees and we can tell there's something there, but there's no light, so we don't get any shadows or anything. So we need to add a light. And I was thinking a good introduction to scripting would just be a simple thing like having that, moving that, adjusting that light to simulate the passage of time. So in most of our game engines, we'll go ahead and just add the light here. In most of our game engines, we have three types of lights that we can use. And some of the really nice ones, there's subclasses of those lights. I'm going to add a new child node. Godot has the three basic ones. So if we search for light, we'll see these three. Spotlight is kind of like a stage spotlight. There's the source of the light, and then it projects out onto a single object. Uh, Omni-light is just what we would call ambient lighting in normal everyday conversation, that where you can't really tell where the source of the light is. There's no glares anywhere. It's just kind of bright everywhere. Or directional light is where light's shining in from a direction, kind of like the sun uh, coming in. Light all comes in from the same angle. So I'm going to go with this one. So let's add a directional light, and I'll rename it sun because definitely going to refer to that in the script. And in most of our good game engines, it doesn't really matter where we locate that. If I bring it up here where it's somewhere in the scene, what matters is the direction it's pointing. Just having it in here, if I hit run, you can see now start to see the shapes and stuff. Haven't set up the camera to turn or anything, but we can see our trees clearly. We're kind of standing in the shadow of something. I guess if we see it here, we can rotate down, get different angles, and this thing I'm doing right here would be how we kind of simulate the passage of time, right? Like comes in at a very shallow angle early in the morning, comes down midday, it's pointing straight down on us, everything's really bright. The shadows are all directly below the thing. And as it continues through the evening down to sunset, and then when the light's pointing away from us, that's kind of like nighttime. So that's what I had in mind to simulate the passage of time with a script and start introducing some of these concepts. So I'm going to reset this 0. Again, in most of our game engines, the position of a directional light doesn't matter. The lights come in that angle no matter where we position it. And we have lots of controls over lights. There'll be more to talk about that later. So like I mentioned sunrise and sunset. So at sunrise, we probably have some tint to the light like this. And then sunset, more of a orangish tint, and it affects how our materials look and everything depending uh, depending on the color we're getting from it. And we have lots of control over that. That's getting into details that we'll talk about in a later video. I'm just going to go with a white light for now and start in the 0 position. And if I grab the red circle to rotate around the x-axis, you can see as we start going down, like go through the morning and approach noon, the numbers are getting negative. Oh, my mouse was in a bad spot. As we keep going, it gets more and more negative. And then our inspector panel is showing positive numbers. That is just a formatting thing. So the degrees here and doing the 180-degree rotation, like some of y'all might know from trigonometry class, that is just a formatting thing. We actually need to work in radians. I'll talk about that in a moment. But if we start this light, then we'll just have the script rotate that around the X to get to that. And all of these things we see in the inspector, those came from a script that's already written. So we can access all of these because we will inherit from the script that these values are coming from. These properties like the color of the light, the factor Boolean, or whether shadows are on or off. We probably want shadows on. You can see the passage of time a lot better when we rotate that way. Go through night and day. So make sure that checkbox is on. But important for us is we can access this rotation. So rotation is a vector, like we were talking about, as X, Y, and Z components. So we can just access that from our scripts. We'll get there in just a second. Let's go ahead and add a script and talk about scripting in game dev, and and jump right into this introduction, a simple introduction, much simpler than what we want our player to do, because then we'll work our way up to the player script. So obviously the first thing we need to do is attach a script to our sun here. So I'm going to right click and attach a script. And fancy, it inherits from directional light, which is basically all of these data fields and some other methods in script form. All these things we see in the inspector panel are data fields in this directional light script that we're inheriting from, so we can add stuff to that and extend it. It's our default script, which is fairly consistent, and we'll save it over in the scripts folder called sun. And Godot here has their own language to work with. It's based off Python with some modifications. One of the slowest things about Python is it's dynamically typed, and Godot script, we could leave it as dynamically typed, or we can switch it to strictly typed, and we get a lot of speed back if we type it as do strictly typed. So I'll be doing that way. Some of our keywords change. I'm going to get rid of this text that doesn't have any purpose. The stuff that doesn't do anything. There we go, and get down to just useful code. And this is a good example of what video game scripts require. I'll start at the top here. It's extending directional light 3D, which basically means all of these data fields, these properties we see in the inspector, we have access to them from the script. We go in and inherit all of those in this script. And then we have two functions here. They change the keyword, so from what it would be in Python, but the rest of that hopefully looks familiar to those who know Python. The name of our function, a spot to enter any parameters, and a colon, and then we indent the block of code that goes with that function. And then stop indenting when we're done with the function. So there are two of them here. This first one, which Godot calls _ready, that runs one time when the game starts. So an initialization function. And then the second one, Godot call it process. That's the frame function. It runs on every frame and takes in this parameter delta. If you weren't familiar with it, frame rates are not consistent. In the early days of game development, they tried making frame rates a hard-coded number, like they'd say 60 frames per second, which is like 16.7 milliseconds. But if the CPU consistently finishes all the processing in like 10 milliseconds, then for almost half of our frame, we're just stagnant. And too many of those frames starts to make it look jumpy. Or if we run out of time, we only have 16 milliseconds for the frame, and it takes 17 milliseconds to do all our processing, then the game's just going to crash. So frame rates are not consistent. So this parameter uh, represents how the length of time for the frame, how long the frame takes. And what the game engine does is it tries to average to the frame rate we say. So if we say 140 frames per second, they're all going to pass at a different amount of time, and the game engine will do its best so that they average to about 140 frames per second. So we'll need to know how long it is, and this is consistent in all of our game engines. We have this function, initialization function, that will run one time, and then we have a frame function that runs every frame. And what varies engine to engine is the name of them. So like in Unreal, this would be called start, that runs one time, and then tick, that runs every frame. Or in Unity, it's start, that runs one time, and update, that runs every frame. And there are some varieties of those. We'll get to those, see some of those before long, or talk about those before long. Uh, Especially on the frame by frame one. There's a lot of variety we can do on how we process each frame of the game. But we'll have those two different names in all our major game engines, but the same thing: the initialization function and then the frame function with access to a parameter for the amount of time the game takes. And this video looks like it's already up to 12 minutes. I want to try to keep all the videos under 15 minutes, so we will actually do the coding in the next video. So I'll see you in that.